We can start with that one. The difference of perfect squares factors into conjugates. And those conjugates are comprised of the square roots. Conjugates comprised of the square roots. So if they're perfect squares, they have square roots. And that's what kind of builds the conjugates. So for x squared minus 4, the square root of x squared is x. The square root of 4 is 2. So that x and that 2 make your conjugates. X plus 2, x minus 2. Now, if you know the special pattern and you just do it, that's the goal here. That's the benefit of picking up on a pattern. If you wanted to be sure, again, you can still always check these. X times x is x squared. Your firsts multiply to be x squared. Your lasts, plus 2 and minus 2, multiply to get negative 4. And just check your outer and inner. Minus 2x plus 2x combines to be nothing, right? We already talked about the beauty of conjugates when we were rationalizing, right? When you multiply conjugates, the outer and the inner will always cancel. That's why we don't have an x term. It's x squared plus 0x, technically, minus 4. We lose that middle term because the conjugates never multiply to have a middle term. Okie doke? What's the square root of 81x squared? 9x. And what's the square root of 1? 1. Is it the difference between those two? Yes, because it's minus, right? So 9x plus 1 and 9x minus 1. And what's the square root of x to the 4th? X squared. X squared. And what's the square root of 81? 9. So we have an x squared plus 9 and an x squared minus 9. And oddly on this one, we're not done. Which one of those two factors, the first or the second, is still factorable? The second one, because this one is also the difference, there's your minus sign, of a perfect square and a perfect square. What's the square root of x squared? What's the square root of 9? So x plus 3, x minus 3, and obviously also bring down. So this one actually factored into 3 factors because one of the original 2 could go further. Okay, so look for that too, because that will come up and you have to make sure you completely do these. Okay? Let me just jump down. This is brand new to you. And this is going to take some practice. It's going to seem confusing at first, but stick with it. With perfect squares, we can only factor when it's the difference. The sum of perfect squares, like right here, for example, is prime. What does prime mean? Has no factors, really, other than 1 in itself, right? Yes? Did you notice that on the directions last night? It said if something was prime, write prime. There are things that aren't factorable. And if they're not factorable, they're considered prime. Does that make sense? You know what a prime number is, right? 7. Because you really can't factor it into anything other than 1 and 7. Same thing is true for polynomials. But anyway, we can only do the difference of perfect squares. We can't do the sum. Perfect cubes is a little bit different. There is a rule for the sum of perfect cubes and another rule for the difference of perfect cubes. And it looks like this. So generically speaking, we'll do the sum first. If I take something that's a perfect cube, like a cubed, and it's going to be added, so there's your sum, with something else that's a perfect cube, so I'll use b cubed. This factors into not conjugates anymore. So unfortunately, conjugates we wish because that's really easy, but not conjugates. It factors into a binomial times a trinomial, and I'm going to tell you how we fill those in. The binomial is made up of the cubed roots of each of those. So what is the cubed root of a cubed? A. And what is the cubed root of b cubed? B. And whatever that sign is, if that's a plus, this is also a plus. So that's how you get the binomial. The binomial just comes from the cubed roots. Simple enough? Now, to get the trinomial terms, I use the binomial terms. So whatever the first term is, a in this case, I square it and it becomes the first term of my trinomial. Whatever the second term is, b in this case, I square it and it becomes the last term. And by the way, that's always positive because you're always going to get that by squaring something. So that's always positive. The middle term of your trinomial comes from multiplying those two together. What's a times b? ab. So that's my middle term, and the middle term always takes on the opposite sign from the binomial. So I've never used this before, but I think it's worth using now. There's something called SOAP with this that some of the math teachers use. It's like an acronym that stands for same, because that sign is always the same as the original. O stands for opposite. That middle sign is always the opposite of the original. And then this one is always positive. So this little acronym of SOAP can help you remember your signs at least. Same, opposite, always positive. If that helps you. Okie doke. Now, the difference of perfect cubes is pretty much exactly the same. Just your signs will be different. So it also factors into a binomial and trinomial. The cubed root of a cubed gives you your a. The cubed root of b cubed gives you your b. So there's your binomial. If we're using the same sign, what sign are we using? Minus. We square the a to get the first term. We square the b to get the last term. And we multiply them together to get the middle term. And it's same, opposite, so that would be a plus, and then always positive. So that's going on a flashcard because you have to know those. You have to know that structure, okay? That's just like memorizing this. By the way, this is going on a flashcard too. Factor a squared minus b squared. Factor a cubed plus b cubed. It's just facts that if you don't know and a question comes up on the Regents, you literally have no chance. Okie doke. So perfect cubes here. What's the cubed root of this? X. What's the cubed root of this? 2. So set up your binomial, trinomial. X and 2. What sign do I use? Positive. Plus. Alexa, I want you to take a stab at the first term of the trinomial. What do you think it should be based on what I've said so far? X squared. Perfect. X squared. How about the next term? The middle term. Jack Taylor. Negative 2x. Got that? He just multiplied these two together. Flip the sign. Last term. Jack Birmingham. Plus 4. Wow. Look at this crew. Next one. Now, the trickiest part of this one, I think, is what is the cubed root of 64x to the 6th? Start with a 64. What's the cubed root of 64?
4.
4. What's the cubed root of x to the 6th?
2.
X. Who said that, Owen? Yep. Nice job. Cubed root of x to the 6th is kind of like asking yourself, well, how many times is 3 going to 6? Twice. What's x squared? So when we set this up binomial, trinomial, that's a 4x cubed for the cubed root of 64x to the 6th. I didn't say that right. It's 4x squared. Cubed root of 125? 5. And what sign goes in between them? Same, right? So if that was a minus, this is a minus. So coming up with that, I think, is the hardest. And then just being careful. What is this first term when you square it? 16x to the fourth. Very good. What is the middle term if you're multiplying these two? 20x squared and what sign? Plus. I barely gave myself enough room here. And the last term squared is?
25.
Plus 25. It's not terrible, right? It's more complex than the difference of perfect squares. I'll definitely give you that. But you just kind of have to slow down with it, especially on this one. What is the cubed root of 27x cubed y cubed?
3xy.
Y.
Yes, Chris. 3xy. So set up your binomial, trinomial. Cubed root of that is 3xy. What's the cubed root of 1? 1. Same sign is negative. Natalie, what's this term going to be when I square it and put it over here? 3xy times 3xy is going to be 9x squared y squared. Good. 9x squared y squared. When I multiply these two together, 3xy times 1 is just 3xy, opposite sign. So plus 3xy. And the last term squared is just plus 1. So those are your special cases for which you have to memorize something. Go back to the top now. These are special trinomials. You should be able to factor these trinomials by guessing and checking or by splitting the middle term like we learned yesterday anyway. But there is something to notice about them. And I will tell you, if you were to factor this by, let's say, guessing and checking, it would be x and x, positive 3 and positive 3. Does everyone agree that that works? Okay? So let's pretend you didn't notice this special pattern. Now that you see that answer, what's special about this? It's the same factor twice, right? So the more efficient and condensed way of writing this would be x plus 3 squared, right? When something, in this case it's a trinomial, can be written as something squared. For example, let's take the number 25. 25 can be rewritten as 5 squared, right? We all get that? So what do we call 25? What type of number is it? It's a perfect square. When something can be rewritten as a number squared, it's called a perfect square number. Likewise, this is called a perfect square trinomial because it can be rewritten as something squared. Does that make sense? So here's the special pattern from the original that you might pick up on, and then you'll be able to tell, oh, this is a perfect square trinomial. Something's going to be a perfect square trinomial if the square root of this is a perfect square, which it is. What's its square root? X. This is a perfect square. What's its square root? 3. And if you multiply those two, you get 3x, right? If you multiply this square root times this square root, you'll get 3x. And the middle term is double that. If those properties hold true, it's a perfect square trinomial. Because think about what happens when you FOIL out something times itself. X times x, you'll always be multiplying something by itself. That's going to give you a perfect square. And on the last two terms, you're always multiplying something by itself. That'll give you a perfect square. Your outer is 3x. Your inner is going to be the same thing again. And that's why that middle term sort of doubles. Does that make sense? So look at this one. What's this one's square root? 5x. What's this one's square root? 6. Now, When you multiply 5x and 6, you get 30x, right? And isn't the middle one double that, but just with a minus sign? And if it's a minus sign, you just put a minus sign, and that's it. 5x minus 6 times 5x minus 6 will give you that. So if we were trying to fill in that middle piece here, to make this a perfect square trinomial, who thinks, raise your hand when you think you can tell me what you'd fill that with. Oh, 3 hands just went up simultaneously. 4, 5, looking good. Jason, you don't look like you're trying very hard.
I was thinking about it, I had no idea.
Haley. 10x. Correct. Can you explain to your friends that didn't have a clue how you got that?
Well, I took the square root of x squared, which is x, and then the square root of 25, which is 5. And then I multiplied x, it would be 5x, and then doubled that would be 10.
Beautiful. See that? So she doubled it and got 10x. The last one's just a little bit different because we know the middle term. But what would the last term have to be? Oh, 2 hands already. 3, 4, 5. Wow. Look at this. I got faith in you, Jason, though. You know it has to be a what? A perfect? Has to be a perfect square. And the square root of this one is what? X. And the square root of this one has to be something that when I double it is going to give me -8. 16. Very good. Your homework, 39 to 63 odds on that same worksheet. That was a good day. We had a lot done. 2 quizzes. That's good work for a Friday.